So our first speaker is going to be Jeff Houston from APNIC, who's going to speak to us about IPv6 and deployment thereof. So thanks.
Green button. Good morning all, my name is Jeff Houston. I work with APNIC, which is the local regional internet registry servicing addresses for the Asia and Pacific region. I'm not going to talk about addresses per se. What I want to talk about today is actually a subject that has been at NANOG a few times. And it's a subject about IPv6 and performance. Because of course, there are kind of two suspicions about IPv6. One, it's hideously unreliable, and two, it's as slow as all hell. So you'd only deploy it if you really hate your customers, right? What I'd like to do is look a little deeper into both of these questions and actually look at to what extent have we managed to make the v4 network that we currently all use so crappy and unreliable with carrier-grade NATs and all kinds of performance bits and proxies, so abominably bad that v6 can only look better. Have we got to that point yet? Or is v4 still actually managing to work well? So how well does v6 do in comparison to v4 on just making connections? And secondly, that perennial question, which is faster? Is v6 still the sort of wonky cousin with one eye, or is it actually now managing to get much the same performance figures as v4? So what I'd like to do is sort of describe very quickly how we do this measurement. There are various ways of measuring the networks, and you probably have your own favourite method. I don't run a network anymore. I can't see inside your networks per se. But there is one thing out there that you all experience, and that's those intrusive online ads. Now, the thing about ads, which is really quite insidious, is that you can script them. Ads can become dynamic, and you don't need to click. And in my case, please don't click on my ad, because then I have to pay money. As long as you don't click, I can actually generate something on your screen that executes code. And as long as you don't click, it's free for me too. Now that code is really very, very simple. It just collects a number of URLs. One is v6 only, one is dual stack, one is v4 only. But the DNS and the target URL are my servers. So every single time this ad executes somewhere, all the traffic comes back to one of my machines. And I'm logging everything I see on those machines. So I use Google, thank you Google, and for a while there I was doing a few 100,000 ads per day. And then Google decided somewhere around the middle of last year that, they would be super generous, and over Christmas, thank you very much Google, they decided they'd be extra special generous, and we managed to peak at a little over 10 million measurement points per day. The thing about ads is they're all unique users. They are pulled from all over the internet, and you get astonishingly large numbers of samples from literally every single network out there that has customers. So the measurement count spans the entire internet, even the Faroe Islands. Hello, sheep. It spans the entire internet, and it spans it pretty well. In a log scale, what you start to see is how much of that is v6 capable. And it's around 5%. Yes, I know Google say 10, but they count the number of folk who visit Google versus the number of folk out there on the internet. And yes, there are a lot of Chinese users. Once you start to sort of even it out and talk about the world as it exists, around about 5% of the world currently are doing v6 in terms of being capable of collecting something. So I said I'd talk about two things: how reliable is it and how fast is it? Let's look at reliability. Do connection attempts succeed? Now, one of the ways of looking at this is to look for naked sins. Naked sins are when the TCP handshake fails. You're trying to connect to me, so you send me the opening TCP hello packet, the first sin. My system will go, fine, I see you, here's a sin ACK. Now you're meant to say, got it, here's the ACK to complete. But what if I never see that final ACK? That's the point where there is some kind of failure going on. And you can start measuring this. Now, I measured this a couple of years back, basically in 2011, 2012, when Teredo, remember Teredo? You shouldn't, it was shit. Teredo and 6-4 were still active, and there was little else in the way of IPv6. And just to compare it, I did another measurement across all of last year and a bit of this year. And I want to compare those two data sets. In 2011, you deployed V6 only if you were religious or crazy, or both. The failure rate was abysmal. 4 out of 10 connection attempts failed on the opening SYN handshake. You'd really have to test your customers to think about running V6 in that environment. That's the green line. The red line, by comparison, was V4, was looking just fine. So there was a real question, why was V6 so shonky at the time? And even in V4, there were kind of spikes and noise points. So what was going on with V4? Even in 2011, what we actually saw was a huge amount of botnets scanning the V4 space. And any kind of measurement system in V4 these days has to account for the fact that all of the time folk are scanning all of the address space. And some of them simply say, well, who's going to respond on port 80 with a SYN? Who's going to respond on port 443? They're not interested in completing the connection, they just want the SYN ACK to show that that address is active. And so we see a fair deal of that as part of the background toxic radiation in V4. So far, the laws of very, very large numbers in the age of the universe have stopped folk doing the same in V6. You just can't scan the V6 space in real time unless you've got some kind of bizarre time warp going on. So for V4, basically background scanning and radiation and a couple of SYN attacks. Whoopie-doo. V6. With V6, you can actually tell what kind of V6 technology is being used by the source address. And what we actually saw was, at the time, Windows was still using Teredo, and there was a lot of Windows boxes out there. So Teredo has a connection failure rate of about 50%. So if you're running Teredo, you were condemned to a world of misery and pain. No wonder folk just turned it off. Even if you're running 6-4, the failure rate was around 1 in 5, which for any kind of network, if you're running a 1 in 5 connection failure rate, you'd go home or resign. I mean, it's crap. Unicast V6, the red line at the bottom, was certainly looking better. So why? Why is 6-4 so absolutely abominable? The thing is that there are two problems going on. One is, of course, the whole issue of path MTU. Tunneling is bad. Whenever you add another packet header to a packet, you encounter problems with fragmentation and MTU issues that some networks do not resolve clearly or easily. That's bad. But more to the point, everyone runs some kind of filtering and firewall rules for incoming traffic. And there's an awful lot of folk who say protocol 41 is unknown, throw it out. So you can send out a packet, but you never get one back. So around 10 to 20% connection failure rate is self-inflicted damage. Folk are running firewalls and filters out there in front of them that just simply block the incoming traffic. What about in Unicast? It's still not brilliant, and across that period in 2012, I measured about 110,000 sample points, and I was trying to find out, I'm like, are these V6 addresses things that folk can't type in properly? Are we getting linkage of link local? What's going on? And what we actually saw is that failure rate had a small number of folk using FE80, some folk using that unique local address as a source address, but predominantly it was standard unicast just wasn't working properly. So we move on to something more recent. I measured across all of 2015 and a bit of this year, 2016, and certainly a lot more endpoints, 37 million. So a lot more of you using V6, well done. Failure rate still pretty shit. 3.5% is not exactly brilliant. That's the failure rate per day over that period. And there's actually one sort of discontinuity going on. For those of you who care, Flash finally died. Adobe Flash is no longer being used in the ad network, and that was on the 1st of September, and that was a good thing. Since then, all the measurement work has been done using HTML5, And what now I get is I get clear visibility onto all those mobile devices, including Apple, which always had this religious problem with Adobe Flash. So I actually see a slightly better view of the network, and oddly enough, the connection failure rate has improved. On 6 to 4, I saw 7.5 million of them, but the connection reliability in 6 to 4 is still basically lousy. Tunnels don't work. Tunnels really are evil, and you shouldn't be using it. Of all of the IPv6, 20% with inside the set of 6 to 4, 9% of 6 to 4. So what can we say there if we break it all up? The blue is the failure rate of 6 to 4. It's still really high. The green is the total, and the red below that is the unicast, the stuff that isn't being tunnelled. So V6 is okay, but it's still not brilliant. Teredo has disappeared, and unicast V6 is failing at around, 1.5 to 4%. Some of you have got the message. 6 to 4 really is shit. You should turn it off. And the good news is that over the last 13 months, it's gone from almost half of the V6 network down to around 7%. That's really good, because 6 to 4 really sucks. The fact that it's 7% is still really bad. You should get rid of the rest of it. Whatever, kill it. Of the rest of the failures, what we see is 138 folks still use Teredo. Congratulations. Bad ideas never die, do they? They just never, ever, ever die. There's still some stalwarts thinking that linked local means global. Good on you. 834 folk aren't routing the address they think they have. Well, that's never going to work, is it? And 1,244 aren't being announced in the routing system. If you want to see packets, you've got to announce them in routing. And of the rest, around 216,000 64s comprise these failures. So who fails? These are the highest failing networks. If you see yourself there, you should think very hard about what you're doing, because this is not the good list. This is the bad list. This is the list of disaster. If anyone's here from AS 30036 Mediacom, watch out. You've got a serious problem going on inside your network. It's about a 30% failure rate. This is not a good idea. On the other hand, there are folk who are doing it right. And if anyone's here from the University of Iowa, you watch an awful lot of YouTube, you see an awful lot of ads. But the good news is all the V6 stuff is working perfectly. Fantastic. So, there are folk who can do it right and do it reliably. And out of all the samples, there are absolutely no failures whatsoever. So if you're on this list, and if you see yourself, well done. What about the V4 connection failures? A couple of years ago, 0.2%. What do we see now? Well, 500 million sample points, which is probably a reasonable sample point for the internet, 500 million. We saw 1.1 million connection failures, which is around 0.26%. Over that period, 13 months, I missed some data there, sorry about that, but it's sort of roughly between 0.4 and 0.2%, declined over time. If you compare it, I've added a line at the bottom that says V4. And significantly, V4 is better than V6 no matter what. If I compare the two unicast, V4 is significantly better than V6 no matter what. If I just blow up the last 4 months, you know what I'm going to say. What about the ratio of the two? V6 has about 7 times the failure rate of V4. 7 times the failure rate. It's still not there. There is still this annoying kind of issue that not all the connections make it through. And that's just annoying. So V6 around 1.6 and falling, V4 at 0.2%, things have to get a bit better than that. So the other half of this talk is actually trying to look at the other thing. Have we managed to make V4 so toxic that it just doesn't work well anymore? Do all those carrier-grade NATs and state transitions and binding tables make the entire V4 experience incredibly slow? Because we don't, in theory, have all of that stuff running in V6. In theory, we should be able to sort of see in performance. Now, how do you measure performance? Because in looking at a standard application, the problem is you're measuring a number of things at once. Not only are you measuring the network and the network path, but you're also measuring the behaviour of the application itself. That there may be a delay in the next packet, not because of the network, but because of the application scheduler, the browser, a whole lot of other things may be intruding. So what I tried to do is strip most of that out and look at the one thing that actually doesn't have a whole lot of cruft associated with it internally. When you say into your operating system platform, connect, the resultant SYN-ACK exchange operates basically at the kernel level. It operates at that level of an I/O connection that does not get interrupted by user-level processes. So in that case, what I'm looking at is, what is the time to complete that handshake? Now, in theory, I get a relatively clean measurement. That's good. However, I only get one measurement per session. That's bad. So, it's kind of compromising between what I could measure and what I think is the most reliable measurement point amongst all the ways I could do this. So the next thing you do is you go, well, I'm just not going to take all the V4 and V6 measurements and compare them. I'm only going to take those subset of the measurements where that person over there responded to me, the same server, in both V4 and V6. So that I'm only looking at pairs of measurements between the same two endpoints where I've got both V4 and V6 paths working at the same time. And what I want to do is compare the round trip time in V4 and V6. So the way I do this, to associate your V4 and V6 address, because you're not going to tell me this gratuitously, is I go through the web logs and I make sure that, if you will, the same unique labels that were inside the V4 fetch are inside the V6 fetch. So now your browser has given away the fact that you're the same person doing both of these protocols. And then I go back into the PCAP data and actually look at the SYN exchange to pull out the round trip time. And then I divide this into 0.1 millisecond buckets and actually find then a profile of difference of RTT. Did this a few years ago. And this is 2012. The red is Teredo, the green is 6-4, and the blue is unicast. And if it's off to, now let me see this right, if it's off to your right, V6 was slower. If it's off to your left, V6 was faster. Back in 2012, V6 was obviously slower. What was going on was that, particularly in Teredo, red, and in 6-4, green, and even in unicast V6, most of the measurements were pointing to the fact that V6 had longer RTTs than V4. Why? Most of you are tunneling, and tunnels are bad. Tunnels invoke loud delay, tunnels invoke MTU problems. It just got worse. This is the more recent data. It's just 2 months of data. This is unicast V6. It's actually quite difficult to figure out from that graph whether V6 is slower or faster. I'll show you a few more data in a few more slides' time, but as you see, the picture for unicast has changed quite dramatically, and then what you're seeing now is a more uniform sort of spread of statistical variation around a mean point. 6-4, on the other hand, is quite predictable. 6-4 sucks. There's no other way of saying it, it's just slower. Don't use it, it's evil. I can compare the two and you can see what's going on there. If you actually put the two together, what you see is it's pretty obvious 6-4 just doesn't work very well. It is a whole lot slower. But unicast is interesting. So let me use a subtly different statistical technique called a cumulative data distribution and actually plot, if you will, the percentage of samples that were below a certain point. So if you look at it, almost all of the samples in V6, from approximately 13% to approximately 80%, V6 was as fast as V4. No slower, no faster. Whereas with 6-4, almost 60% of all the samples were slower. So V6 is looking surprisingly equal to V4. Let's blow up just around the middle point, and this is looking at the 80 millisecond of time difference just around that 0 point. 13% of the samples, and there are a lot of samples, V6 was more than 10 milliseconds faster per round trip time. That's pretty freakishly good. My suspicion is that V4 is pretty freakishly bad at that point. because you can't go faster than the speed of light. 32% of samples of unicast V6 were more than 10 milliseconds slower. I suspect there are structural transit tunnels out there. Folk who were standard tunnel providers are still providing a lot of V6. It's time to get rid of them because that affects the performance of these sessions. The 0.44. 44% of the time V6 is either the same or faster, 56% of the time it's that shade slower. But that's not bad, that's actually pretty good. So we can start to actually get now to the question that I asked right at the front, to give you some time for questions. Is V6 really as good as V4? Well, if your parameter is fast, is it as quick? Then frankly, yes, it's as good. Half the time it's faster, half the time it's not. 65% of the time it's within 10 milliseconds on these measurements. That's good. So it performs at about much the same rate. If you use 6-4, get out of here. You know, you lose. There's no other way of saying it. But if you're on unicast, you're kind of there. It is as fast. But the other parameter, is it as robust? The answer is no. And it's not your fault. I don't think this is structural problems inside your networks. I really don't. I actually think that this is the same problem as we've always faced. Absolutely shocking CPE that has default rules and default filters that just work against what users are trying to do some of the time. And I suspect the reason why we're getting these failure rates is because the incoming V6 packets are being rejected by gratuitously weird filter rules. We could do better in that respect. And until that gets lower, because it's not good where it is, until that gets lower, 1 in 50 isn't good enough. It has to be 1 in 500 or lower. And that means that the CPE needs to be a whole lot better. A whole lot better. If we can do that, then V6 is as good as V4, no questions asked. But until we get to that point, there's still this niggling suspicion that you need V4 as your backup just in case. Because in 1 in 50 cases, you will definitely need it because you just can't do the connections in 6, and that's not good enough. So if you can establish the connection, yahoo. If you can, you're just there. It will work just at the same rate and the same speed. The odds of doing that are weighted in favour of V4, and that's today's picture. Hopefully it will be better in a few years' time. We will see. Thank you. Questions? I saw a jump first there.
I jumped right up. Yeah, hi. My name's Nick Holt from Microsoft. Do you have any data on how many clients came to you only on V6? That's one of the other interesting questions, is are there people out there that do not have the fallback to V4 that we have to treat?
The question was, is there only V6 out there? Part of the issue is actually the advertising network here. And there is no V6 only advertising distribution channel as far as I'm aware. So that most of the channel that establishes the connection is done in 4. So if you're 6 only, you might be in that happy world where there are no advertisements, or that, from my perspective, unhappy world that I can't see you. But my experiments start with the predicate of launching the experiment at you in 4. So I can't answer your question, I'm sorry.
Right, thanks.
Middle microphone.
Hi, Chris Woodfield with Twitter. Did you do any measurements on the impact of 6-4 fallback? Like how long does it take for typical clients to fail to reach you on V6 and then come back to V4 and successfully load the ad?
You know, to make this work, what I need to do is something really quite subtle, which is stuff around with the DNS and to give you a V6 address for my service, which is unique to you. Now, I have 64 bits to play with, and I could do this. So the first sin I ever get from you in V6 kind of tells me who you are, no matter what. I've been thinking about doing this for years, and I confess I'm lazy. I haven't got there. So the answer is I don't measure it. I think I know how, and I just need some time, a spare day, to actually code it up so that as soon as you try and connect to me, The destination address that you use for me tells me who you are. So far, no, I can't quite track just the sins, but I'm thinking about it.
Okay,
Thank you.
David Farmer, University of Minnesota. For the V4, do you have any way to tell how many of these are naked V4 versus natted V4? Or
How can you tell whether it's a naked V4 or natted V4? So there's one way of inferring this,
yeah,
and the experiment actually does is it launches a bunch of connection requests and tells the user to go to sleep for 10 seconds and then send the result. Now, a lot of NATs lose their bind within 10 seconds of idle, and the result comes back on a different V4 address. If you live in Ethiopia, no one's putting their hand up, the chances are around 48% that 10-second response will be in a different V4 address, because there's obviously something that's futzing around with the public addresses. If you live in China, it's around 30 to 35%, no questions asked, that you'll come back with a different address in 10 seconds. Is this a reliable measurement of the full extent of NAT? No, not at all. Is this a pointer? Yeah, it's a pointer. And things vary network by network. And if you want to hear more about it, I'm sure I could do a presentation at some future NANOG about precisely measuring what's out there with address permanence and NATs. Yes.
well, part of why I was asking is you were asking, is V6 better? Well, is V6 better than what? Naked V4 or natted V4? And if the two are mixed together, you get some mumble jumbo.
The two are mixed together, David. I'm comparing all of V4 in all of its glory to unicast V6, because 6 to 4 is evil.
Yeah.
Thank you.
Hi, Dave Temkin, Netflix. I guess to that point, well, first, I want to say thank you for getting up and giving a talk that wasn't an IPv6 cheerleader. Basically, exercise in telling us how great V6 is. When I first saw it on the agenda, I was like, oh, great. We get to kick off with someone telling us, more V6, yay. So anyway, to that point, how do we get the word out that 6 to 4 is no better than natted or naked V4 for that matter, and tunnels need to die also? Because that's the other thing that I took away from this, is that V6 tunnels in general are adding almost no value, and the fact that you're seeing them in major pieces of infrastructure, to me, is part sad, part hilarious.
You know, Dave, I think it's probably time to increase the bandwidth of the relationship with some of these access networks, to talk to the Comcasts, the Verizons of this world, the Deutsche Telekoms of other worlds, and to say, can we share with you source data? Can we actually tell you where you've got folk who are still deeply damaged because they're using the wrong tunneling protocol? And maybe it's come to that point where we actually start mopping up individuals. We're down to 7% 6 to 4, which is pretty good,
Yeah.
but 7% still 7% more than it should be. And I'm not sure that general exhortation, get rid of it's now really necessary. I think we now zero in on the offenders.
Yeah.
And I think it's probably time that we sat down with these providers going, let me tell you about the way we see your customers and where we see problems, and see if we can't work it out. So I'm happy to start that dialogue.
I think that'd be great. You know, from our perspective, from a Netflix perspective, we're constantly asked, hey, why isn't more V6 out there? And I couldn't answer that with less than 10 minutes of discussion, so I won't go in detail there. But what I can say is, so long as that failure rate is greater than 1%, the odds of me pushing forward when the failure rate is at the CPE are much lower than if that failure rate was in line or better than V4.
I understand where you are, exactly.
Thanks.
Thank you. Tony.
Sorry, Tony Tauber, Comcast. I mean, I guess as a follow-on to Dave's question about NAT, mobile networks, particularly carrier-grade NAT in V4, and I guess in some cases in V6 is really the norm. Do you see a big discontinuity, or, I mean, can you tell which ones are mobile networks and, you know, kind of the effect of the carrier-grade NAT?
I'd like to say yes, but the problem is that you turn on your mobile device in Wi-Fi networks and you'll appear with the same signature.
Right.
And there are carriers out there that offer mixed mobile and wired on the same AS, some of them distinguish. I thought I could do this, and I looked at the data and said, look, I'm just terminally confused. I can't isolate access networks by this mechanism. I can infer stuff, but it's not very reliable. So no, I'm kind of in the dark on that one.
So you're saying the agent ID?
The agent ID is the same whether
Right,
on
right.
Wi-Fi or cellular, so I can't tell the difference. And you know, that's the first part of the problem. Yeah,
Thanks.
thanks.
Doug Montgomery, NIST. Do you have any idea of how your performance measurements might scale with traffic volume? You're reporting 5% of your users who hit the ad appear to have V6. If that was 100%, do you have any intuition?
Google upped their ad presentation rate on me from just under 1 million to 10 million a day over Christmas. Thank you, Google. And it's almost the same as having all these new V6 users. It was certainly a shock to my system to have to suddenly change a whole bunch of parameters to cope with the load. I use rented nodes all over the globe. If I really need more of them, I just rent more of them. Yeah, I could cope with a much larger measurement system. I'm now pretty confident of that.
No, I
more
wasn't
V6
concerned
in the
about how
mix.
your measurement system would scale. I was concerned about whether any of the performance artifacts you're seeing are a function of scale.
I don't think so. It's not clear that it's a function of scale, what we're seeing here. Connection reliability, the TCP handshake runs with a very, very conservative RTT estimate, so it's quite tolerant of waiting for that SYNAC. So I'm not sure that things would really alter that way. But you know, if the folk who are saying V6 is coming are right, we're going to experience this, Doug, and we're going to measure it as it happens. So either way, time will tell. Thank you. We'll probably cut the microphone lines off after this round, so Bill, you're pointing elsewhere.
He was there first.
Okay, centre microphone.
Oliver Guerrero from Yelp. I'm curious, beyond the reliability of the three-way handshake, do you have any data on how many connections might be established but are actually unusable due to NPU issues?
Yes, I do, but I'm actually using a different mechanism. TCP is really quite hard to look into in bulk, but the DNS is remarkably good. And I'm actually looking at MTU issues over 6 and 4 in the DNS, but that's a subject of a different talk. The whole issue is V6 treats large packets differently than V4. The backward MTU notification and the lack of forward fragmentation drastically alters the performance of fragmented packets in 6. And it does have an impact, but it's probably not the time and the place to go into that. Don't use large packets in V6 if you can avoid it. Just do not go there. Be really conservative once you go over 1280 because the failure rates get pretty high pretty quickly, is the basic message.
Cool. Thanks.
Bill.
Okay, so Bill Manning, and no one will affiliate with me, so I'm good. The question I have is, you were talking about tunneling, and tunneling being suboptimal, I guess, is perhaps a good way to put it. Do you have an opinion about VPNs? Since VPNs are in fact tunnels.
Well, the issue about the VPNs even is that you control both endpoints, but you don't necessarily control the middle. You don't actually know which way it flows. What you've added is 2 landscape points. You've got to go to the tunnel ingress, go through the tunnel to the tunnel egress, and then go to the original destination. What we see in 6-4, which exhibits this kind of behaviour, is that it takes longer, it is much, much less reliable, and there are a whole bunch of associated performance problems associated with that. Could I generalise that to VPNs in general? That's a brave kind of assertion, Bill, and I'd be hesitant to make it. But what I would say as guidance is, tunnel if you must, don't tunnel because you can, because you will pay a price whenever you tunnel for whatever reason. But if you have to, you have to. But it's not the first tool in your toolbox. It should be close to the one of last resort if you want robustness and performance out of your system. John.
John Curran, Aaron, great presentation, Jeff. Following up on what Tony asked, have you done any cluster analysis to see if there's groups of ASs that have distinctly different ratios in terms of performance, or connection? Because while you can't necessarily identify them, I would expect that some of the devices that are using different clients, when you actually, instead of averaging it all together and saying V6 is 50-50 with respect to V4, I imagine there's some ASs for whom it's permanently different. And I'm just wondering if you did the cluster look of that.
Backwards, 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 backwards.
I was asleep during it, okay.
So, you know, it is possible to isolate the folk who are consistently pretty bad. And just to make sure I've given you the sample count, some of the ones with low sample count, like monkey brains in the US, whoever they might be, I only saw 126 times. So the fact that 1 in 5 failed, it's hard to take. But Mediacom, I saw them 60,000 times.
Right.
So that 1 in 3 failure is pretty solid.
Right.
You know, there's a problem in Mediacom, and you know, the numbers show it.
My question is, have you done that with the V4, V6 ratio?
No, I haven't done that yet,
Okay.
John, and it's a fine suggestion, and I'll have a look at that. Thank you. That's half an hour. I'll hand it back to the program committee. Thank you.
Thanks, Jeff. And Jeff is program gold because he's already pitched at least two more proposals just in the course of his answering the questions. So this is excellent.